Hello. In this video, I'm going to explain problem 25 from the 2013 F equals MA contest. In this problem, we are told that a box with weight W will slide down a 30-degree incline at constant speed under the influence of gravity and friction alone, and then we're asked to find what horizontal force can be applied to make the box move up the ramp at a constant speed. So, let's draw a diagram as always. So here we have our angle. Let's just say theta is 30 degrees. So here we have a box. Now, of course, there's gravity acting. Now the box is weight W, so the gravitational force is, of course, just W. Then, of course, this is split into two components. So if I look at gravity, I'll draw it off to the side. So this is W. Then you'll get a component that is perpendicular to the ramp, and so this will be W times cosine theta, so that's W root 3 over 2. Then the component that's parallel to the incline will be W sine theta, and that's W over 2. So now, what we know that in order to make sure that the block does not fall through the ramp, there's a normal force, which I realize that I did not draw the arrow to scale, but that will be W cosine theta, which will be W root 3 over 2. And now we are told that the box will slide down at a constant speed in this situation, which means that the frictional force will exactly balance out the gravitational force, the component of the gravitational force that is parallel to the incline. So that will be W sine theta, or W over 2. And we know that the frictional force is just the normal force times the coefficient of kinetic friction, which would then tell us that the coefficient of kinetic friction is, W over 2 divided by W root 3 over 2, and so that's just 1 over the square root of 3. So now let's look at the situation where we have a horizontal force P. So let's draw the new situation. So the force P is horizontal, and as you can see, P is not parallel to the incline. And that's important because that means that the normal force will now change, and so the frictional force will also change. So it's very important, the word horizontal. So I will draw it. I'll also draw gravity and the force P in its components from the very beginning. So here we have W cosine theta. Then we have a force P, gravity will also act W sine theta. Now, since we're trying to push the block up the ramp, we're going to have that the frictional force are going to act downward, and that will be Fs, which will be the normal force. There will be a new normal force, n prime, times mu k, and so that will be n prime over square root of 3. And we're going to have to compute n prime. So n prime, so P is going to be at an angle, since P is horizontal, the component of P that pushes the block into the ramp is going to be P sine theta, and then the component of P that pushes the block up is going to be up the ramp is going to be P cosine theta. Notice that for the gravity perpendicular to the incline has the cosine, and the component parallel to the incline has the sine. For the force P, it's exactly the opposite because the P and the gravitational force are at 90-degree angles. So now, the normal force, N, I'm going to draw it off to the side, has to balance the two forces that are sort of threatening to pull the block into the ramp, and so it will have to equal P sine theta plus W cosine theta. And so really, that's P over 2 plus W root 3 over 2. And so now, we can write everything out. What we will get is that the horizontal forces need to be balanced, the forces parallel to the incline need to be balanced. So we will have W sine theta plus the frictional force must equal P times cosine theta, which is the force pushing the block up the ramp. So we get this. And let me just write cosine theta first. And now we can plug everything in, W over 2, plus the frictional force, which is N prime over 3. And we wrote N prime over here. So sorry, that's N prime. And so we will get P over 2 divided by root 3 is P root 3 over 6. And then W root 3 over 2 divided by root 3 is just W, just plus W over 2. And that equals P cosine theta. And that will equal P times the square root of 3 over 2. And now if we rearrange, here we get W, and then root 3 over 2 minus root 3 over 6 is root 3 over 3. So we get P times root 3 over 3. And therefore P is equal to the square root of 3 times W. And so now let's go back to our options. And indeed, we see that the answer is P equals the square root of 3 times W. And so that's all there is to this problem. One thing that you could do is that instead of writing, root 3 over 2 and 1/2 and things like that, you could work it out just in terms of sine theta and cosine theta in general, if you're more comfortable with that. And that could also give you an additional way to check your work. But in this problem, I don't think that that is necessary. All right. So thank you for watching, and I hope that was helpful.